All right, so now we're going to look at reorder point. There we go. So, starting from the beginning here. Reorder points. You can recognize these types of problems when there's a demand rate that's a lowercase d. It looks like this one. When demand rate is in the problem, lead time is in the problem, and desired service level or stock out risk are given. So usually you're going to get risk. You'll see what I mean in a minute. Thankfully, we only need to know and use A and B under the reorder point model. First one is with constant demand and lead time, which is very simple, and the second one is with variable demand rate. These are the two equations that you need for reorder point, and here are the variables that you will use. So in this model, there's 4 determinants for finding the reorder point quantity. One is that you have the rate of demand. It's usually based on a forecast. And the lead time, the extent of demand and or the lead time variability. We're really only going to be working with demand variability. And the degree of stock out risk that is acceptable to management. So if demand and lead time are both constant, in other words, if we know what demand and lead time are going to be, the reorder point is simply that demand times that lead time. Now, when you do that, the rate on the demand and the lead time, they need to be the same. So if it's your demand is 10 per day, then you need to use lead time in days. So days, weeks, months, they need to be the same. The rate needs to be the same. So in chapter 13, there's example 7, where the problem states Tingley takes 2 a day vitamins. This is an example of a really simple one. Okay, so part A of that model. Tingley takes 2 a day vitamins, which are delivered to his home by a route man 7 days after an order is called in. At what point should Tingley reorder? There's the demand rate, which is 2 vitamins a day, and the lead time, which is 7 days. The lead time being the amount of time that it's going to take for it to show up. So it's simply 2 times 7 right there. 2 times 7, 14 vitamins, which makes sense, okay? If Tingley absolutely needs to be taking 2 vitamins a day and he gets down to only having 14 left and he's going to need 7 days to wait for the order, then you get 14 vitamins. Once he's at 14 vitamins, he should reorder because he only has enough to cover that 7 days. So with reorder point variability, okay? So variability is present in demand or lead time. It creates a possibility that actual demand will exceed expected demand. So in other words, if what will be needed by your customers or what you're going to have to use on the job is not always the same, that means that you might end up using or being demanded of you more than what you expect, okay? So because of that, there's something called safety stock. So that reduces the risk of completely running out of inventory. So it tries to address that wiggle room. So the reorder point is then increased by the amount of the safety stock. So what that means is your reorder point becomes what you will normally use with a little bit added in for safety. Okay, so it's expected demand, so the demand you expect, and then plus, and with that lead time, right? So the demand you expect times that lead time for the order or production or however you end up doing it. And then safety stock. So you add in a bit of safety stock to try and stay safe. And that's represented in this little graph here. So that leads us into when we have a variable demand rate. That's the second equation that was in that chart, okay? And of this section is your safety stock, okay? This is your demand times your lead time. This is your safety stock right here, okay? So In chapter 13, there's example 9. A restaurant uses an average of 50 jars of special sauce each week. Weekly usage of sauce has a standard deviation of 3 jars. So that should clue you in that there's a variability in the demand. The manager is willing to accept no more than a 10% risk of stock out during lead time, which is 2 weeks. Assume the distribution of usage is normal. A, which of the above formulas is appropriate for this situation and why? B, determine the value of Z, that's this part in the equation, and then determine the reorder point, okay? So our average demand, that's what the line on the top is, our average demand is 50 jars per week, but we have a standard deviation, which means that we might need 3 jars more or 3 jars less. We're gonna assume more because we always wanna make sure we have enough on hand for our needs, right? So the standard deviation of the demand rate, that's what this means. But that just means we might need 3 extra jars. And then the lead time is 2 weeks. Acceptable risk is 10%. So service level is 0.9. Your service level is always 1 minus the risk, okay? So 1 minus 0.10, that's 10%, would give you the 0.90. So for part A, since only the demand is variable, in other words, it has standard deviation formula 13-13, that's the one for part B is appropriate. Okay, so that addresses part A here. Now let's look at what we need to do in order to find this Z, okay? So our service level is 1 minus the risk. The acceptable risk is 10%, so 1 minus the 0.10 or 10% makes the service level 0.9. And then we look at the Z table, which you'll have a copy of it on your test, and it's also in your book. The way you read this table is you start with the service level number, and you find it in the chart here. Get as close as you can to that number, and that would be 0.8957 here. And what you do is you start by looking at this number, the 1.2, and then you, at the end of it, add on that 8, okay? That's what this section means. This is the first part of the Z number and the end of it there, which is what gives you the 1.28, because you have 1.2 here, and then you add on the 0.08. So your Z is 1.28. We take that number, and we put it back into this equation right here where Z is, and solve. So we have every other number, okay? You've got the average demand, the lead time, the Z value, the deviation of demand. Lead time is squared here for this reorder point formula with variable demand. You solve and you get 105.43. So since inventory items are discrete units, or jars in this case, we round the amount up to 106. And in general, you round up with discrete units, okay? It's pretty much going to be the case with discrete units or like items of inventory in these problems that you do. So, and that addresses all parts of the question, the example question A, B, and C. So our sample test question now. This is a sample of a test question. A shop owner uses a reorder point approach to restocking a certain raw material, so whatever that may be. Lead time is 3 days. Usage of the material during lead time is normally distributed with a mean of 120 pounds and a standard deviation of 10 pounds. So that's our clue that demand is variable here. There's not just a set amount that's used. It's 120 and it could deviate by 10 pounds. At least that's the standard deviation. So if the acceptable risk of a stockout is 6%, you have to pay attention to that risk percentage because that's what helps you find Z value. But if the acceptable risk of a stockout is 6%, the questions are A, when should the raw material be reordered? So what's the reorder point? That's what this question is asking. And B, what should be the safety stock level? So keywords for identifying demand as uncertain is mean of, standard deviation. So words that clue you in that. there's variability. From this problem, at this point anyways, we can pull out that the lead time is 3 days. That's here. That the average demand rate is 120 pounds. You see here a mean of 120 pounds, right? Usage of the material, mean of 120 pounds. And then standard deviation of demand rate is 10 pounds, which is listed here. Okay. And this is the equation we're going to be using. So how do we find that z? Because we don't have that yet. We need that in order to finish setting up the equation. Again, we find the service level, which is 1 minus the risk, or 6%. So 1 minus 0.06 equals 0.9400, right? You find the closest value in the table here, okay? And you start with the z value here on the left, 1.5. You add that 5 on the end. So z value ends up being 1.55. And now we have our z value. Okay, so now we can set up the equation and solve. So we plug in all our appropriate numbers. Here's that z value, right? Okay. Here's the average demand, the lead time, the z value, the deviation of demand, standard deviation of demand, and then the lead time squared. And you end up with this value, which it is a discrete number again, right? Because it's units of raw material in this question. So you round up. You get 387 should be a reorder point, and that allows for you to have enough to cover you during a lead time with a bit added on for your safety stock. And we'll cover that, how we identify safety stock here next, okay? So what should be the safety stock level is the second part of the question. Whenever you're doing reorder point equations, the safety stock is everything to the right side of the plus in this equation, okay? All of this right here. So this is your safety stock. This is your safety stock, right? When you solve for the safety stock, you get 26 point, a bunch of numbers, partial number. But that's, again, that's a discrete unit, so you're going to round up to 27, okay? So definitely make a note that this side of the equation is safety stock for your test, okay? Because it does not list that it is safety stock in your inventory formulas table. And keep an eye out for keywords that'll clue you in that there's a variable demand rate. If you have any questions, we have a couple days before the test, so you can email me, and I'm pretty quick to respond. But I hope this video helps you understand reorder point a bit better.